Good afternoon. I'm Terry Moore from MCCI, and my talk is entitled Keys to a Successful IoT System Design. So, success means many things to many different people. So, I'm going to start by asking you a few questions. Just raise your hands. How many here are IoT suppliers or vendors? So I would say maybe 10, 15%. How many here are specialists in a real-world topic that you want to use IoT in order to do your job? So I would say maybe a similar number, maybe a few more. How many here are responsible for deciding whether to fund an IoT project? Okay, so that's an important point. And how many here are here to gather data and report back to others? Okay, similar number. Who have I left out? Who didn't raise their hand? What don't I know about the audience? So we're starting here because these kinds of questions are, in my experience, the key to being successful in doing IoT system deployments. It's really, really important to find out who your subject matter experts are, because they're the people who really understand, from a system point of view, what it's going to be successful. You also have to find out who's got the money, because they've got to be satisfied that they're getting a return on their investment. And you can see, just from the hand raising, that it's not the same people, usually. So this doesn't mean you're going to be talking to them very often, but you have to understand the context. Usually your subject matter expert, one of the things they're expert in is the funding aspect of their organization. So you have to find out what the subject matter expert wants to do, and you have to find out what do they already know how to do. Because they probably, if you're doing an IoT system and they're talking to you, it's because they don't know how to do it themselves. So your job as the system provider is going to be, find out what they don't know, teach them the things that they do need to know, and then help them with the rest. Building an IoT system, in my experience, is like engineering a building. You start with the fact that every building site is different. Some building sites are on the side of a hill. Some are flat, soft land, hard land. If you have to dig, you can find almost anything. So every building has to accommodate the site that it's going to be built on. Every IoT deployment, same thing. This analogy is very close. Second part is every building client is different. They're using, you might have a financier, you might have someone who is a business. There are many different ways that there are many different kinds of building clients. And the same thing is true with IoT. You've got the different kinds of clients. You've got to integrate with the existing business systems of the people who are using your technology. Every building budget is different and has different economic justification. You build a house for speculative sale for different reasons and with a different budget than if you're building a house to occupy yourself. And you build an apartment building differently than a warehouse. Every IoT budget is similarly different because there are different economic justifications. Some IoT systems are justified by efficiency. Some IoT systems are justified by servicing existing things, like the classic one right now is bathroom monitoring. Some are giving you new capabilities. And some of the work that we're doing often is doing new capabilities, and I'll talk about that in a moment. But that means you have to think about the problem differently in each case. In every case, building or IoT, you can use pre-existing components. The classic for building is the HVAC system. That's typically a manufactured object that you purchase from a vendor. And if you're doing an IoT system, you'll have a database. You typically don't build the database yourself, right? You typically don't build a lot of the dashboard stuff yourself. You don't do all of the libraries yourself. You put it together from things. But in both cases, HVAC system or database for IoT, there's customization because every use case is different. So this means that to be successful, in my experience, and success, I run a company. Success means that you survive the project and you're happy and you go on and get others and you have a good relationship with the customer and the customer is successful. You have to approach the project from the point of view of a very meta aspect. You have to say, what do I need to know in order to help my customer? You can't come in with a pre-canned solution unless, just as prefabbed housing. Prefabbed housing will work in very specific situations, but there's a reason why all houses are not prefabbed. One size doesn't fit all. So you have to find out what the key variations are, and you have to find out who knows or who cares about all of the components. The subject matter expert isn't the only person who's going to be working with the system. There are users. There are IT administrators. There are the staff who are staffing the operation as opposed to the third parties who might be interested in efficiency data. They all have to be satisfied to some degree. The subject matter expert has to become familiar with the choices and the risks associated with the choices. So it could be very possible, for example, to do something custom for a given application, but there might be a lot of risk involved with doing that customization. It isn't that you say no or that you tell the subject matter what to do, it's that you give the subject matter expert enough information that he or she can make a rational decision and be comfortable with that decision and defend that decision. So you learn by asking questions as the system provider, and you respond to the answers that you get, and then you teach, and then you build the solution around this body of knowledge that you have created collaboratively with your subject matter experts. And this is how you build the key part of a large IoT system, which is trust. You have to have a lot of people involved in an IoT system, and that means there has to be a lot of trust. Or you spend a lot of time answering questions, relitigating solved issues, and basically spinning your wheels. One thing that I wanted to emphasize in this talk because of my experience in other industries, it's very important not to try to create value by keeping secrets. Oftentimes, a vendor will try to keep the customer sort of uneducated, so the customer isn't asking them questions about, well, why not do it this way versus this way? In some markets, there may be a justification for that. In IoT, it's not a mature market. You need to be asking questions all the time. You need to be prepared to improvise and react to new information. And some of that information, the most important information, is going to come from your customer. So you've got to teach your customer enough for them to ask you important questions, and then you've got to deal with the questions. And you have to be willing not only to educate the stakeholder, but to educate the stakeholder's funding agency, which is talking in a different way. You've got to be willing to adapt your own presentation style to the needs of the people who need to get the message. Which for me is very difficult, actually, because I tend to want to give too much information. And sometimes people just want a little bit so they can feel comfortable. And engineers, that's, I think, a fairly common problem, is that engineers, you ask them a question about something, how something works, and they tell you everything. Not always helpful. Another thing that you have to do as the system provider is very hard to do. You have to implement before you generalize. It's very tempting as you're writing code. I'm a coder, I'm still writing code today, to be writing code and say, oh man, if I just did it this way, I could reuse this code, I could use 7 different other things. But that's really dangerous in IoT because you don't know what those 7 other things really are. And your customer doesn't really care. In the building industry, which is very mature, they've already learned that you don't overbuild. You know, I mean, and sometimes people curse the people who build. I'm from New York. We're constantly complaining about the people who built the roads that were too narrow 50 years ago for the traffic we're carrying today, and they're very hard to widen and all that stuff. But that was the right decision for the taxpayers at that time and for the context at that time. So don't solve the problem too early. Don't waste the time building an overgeneral solution unless you really know what the use cases are. We all know that the customer, if successful, is going to need to automate and to replicate and to scale. But not only do you need to find out to what end, but when it finally gets to the point of automating and replicating in scale, the reality is going to be different than what you expect today. Because it's IoT. Stuff doesn't happen overnight. It takes, it's construction. It's a year before stuff happens and you go to the next scale. But from our experience, you shouldn't lose hope that you're going to be doing the same darn thing over and over again. In fact, there are we found that there are lots of overlap and reuse opportunities. If you structure your code correctly, the next project you'll be able to reuse most of your code, and you can invest at that time based on that project. You'll still save money on that project. It'll be fine. So let's talk about use cases. So I've got 4 use cases to talk about. I won't focus on my slide. I'll just go into them one by one. So the first use case is a compost processing. MCCI was approached by a small company named WeRadiate in New York, who the founder was very, very knowledgeable about composting and the practices, the commercially important practices for compost. Now, with compost, it's one thing to pile up the stuff. But when you're done with composting, you have to get rid of it. And there are sort of 2 ways that you can get rid of it. You can pay to have it hauled away, or someone can pay you to take it away. And the difference is measuring the temperature profile while you're cooking the compost. If you can document the compost has been above a certain temperature for a certain number of days, people will pay you. If you can't, you got to get rid of it somehow. So this means in the United States, and I think also in Europe, composting is becoming a big thing because it can reduce the amount of gasoline that's spent on the trucks to take the waste from the cities out to the landfills. So there's a big green multiplier in this. So they knew all the economic details and the justification, but they didn't know anything about the electronics and the LoRaWAN. So we provided all of that. But through all of this, there's been just a continual thing of, okay, what's next? What do you need to do next? What reports do your customers need? And what format? Do we have to do it in Google Docs? Do we have to do it in Excel? Whatever. Just continually learning, and as they get more and more things, you have to worry more and more about management and so forth. Second case, working with New York Passive House. In Europe, people are very familiar with the Passive House standard for high-performance buildings. In the US, not so much. But New York is sort of the capital of Passive House design for the United States. And we got involved with the New York Passive House Foundation because they had taken a European standard for passive house construction and brought it to the United States, which has a different kind of climate. And they didn't know, A, do the buildings really perform as well as they're supposed to? And B, how do they perform as the buildings age? So we instrumented a number of passive house and non-passive house certified buildings so that we could really get a side-by-side comparison. And in the process of that, we discovered that one key thing was to design a small power meter that could be put inside the electrical panels. And very small houses, passive houses, are typically quite small by US housing standards. And so there wasn't anything, so we designed something, working with a partner. And we then got them the data that they needed. This was, of course, a research project rather than a commercial project, but it immediately segued in for MCCI into opportunities to resell these meters to other people who are doing similar things, particularly distribution centers who are for retail in the United States. They use a lot of electric power for the forklift chargers, and the power quality and the power consumption is an important business consideration for them, and they want to know. So, but I have to say, before I go on with this, working with the customer to fine-tune what the meter would do and what kind of information it would provide them was critical, as opposed to just sort of starting with a meter and trying to figure out, designing a product and then hoping that it's going to match what customers need. The third use case is a company called Pallidus Sensing. They are a company that was started by a research neurophysiologist at Washington University, St. Louis. As part of his research, he became an expert monitoring mice in cages. It turns out that you need to know how your drugs are affecting the mice, and you want to see how it affects their circadian rhythms and their appetite. So he had designed some Arduino-based things that would give him the data, but there was no remote access. And mice have teeth and they like to chew. You can't put wires in cages for very long. You can do it, but the mice will find it and they're bored, they're smart, they'll chew up the cable. So he had tried Wi-Fi, he had tried a number of other technologies. Nothing really worked for the density of mice in cages in a lab. And so he found out about us through the Things Network. And we did a pilot run, and LoRaWAN is ideal for this because the data rates are low. You can put out one gateway, cover several labs. It just works great. And so he knows more about electronics and so forth than, say, the people that we Radiate did getting started, because he was a PhD who had a lot of lab experience. But again, we've scaled this up now to we're now at I think 10 or 12 universities already monitoring, 50 or so mice cages in each university. And he's starting a business based on this, or he has started a business based on this. And again, we work with him. And so it's a weekly meeting kind of thing. We talk to him. We say, okay, what do you need now? What's next? How do we fix the dashboards? He was able to take Grafana, which we provide. We did all the back end and gave him a Grafana dashboard. He was able to just work with Grafana himself directly. So we didn't have to do that for him. He's very happy. Fourth use case, and then I'll be done. And I'm done with time anyway. It was Cornell Maple, which is...
I'm sorry to interrupt,
right.
But your time is up. Yeah.
All right. Thank you all very much. And there's the contact info. Thanks.